Hi everyone, welcome to my Devlog series where you can follow me making my new open world voxel sandbox game, Voxand. Last episode, we rewrote the engine and updated to LWJGL3. We also added frustum culling, which doubled the rendering performance. In today's episode, we won't be implementing the physics engine. I'm sorry. We will instead add some debugging tools like colliders visualization. But why? Well, as I said in the previous devlog, when we start simulating physics with math, things can only get buggy. So, because we know that our physics are going to bug as hell, we should provide some basic debugging tools at least to see the colliders. At the end of the video, I'll announce something special for the channel and Voxand. There's a lot of work to do, but just before we get started, I noticed that most of my viewers are not subscribers, so if you like the videos and want to support the project, consider subscribing. It helps me a lot. Let's get started. So, we want to draw a collider, which is an AABB, an aligned axis bounding box. So basically, we need to draw 12 lines, because, well, a box is made of 12 lines.
Wow!
But how to tell OpenGL to render a line instead of a triangle? Remember how OpenGL handles rendering? We pass to the vertex shader some list of data, the minimum being a list of points with indices to connect them, and the vertex shader runs once for each point. Then its outputs become the fragment shader inputs, which run for each pixel. We saw that in this devlog, don't forget to check it out. Actually, there's another step in between, the creation of the fragment. When we tell OpenGL to render triangles, it will read the indices, run the vertex shader, and every 3 points the graphic card will rasterize a triangle, which means it will fill the shape with pixels and run the fragment shader for each of these pixels. And actually, GL draw elements can have a lot of primitive types, like line or point. For points, for example, the vertex shader runs for each vertex of the model, and then only one fragment shader call is done to calculate the color of the pixel where the point is. And for lines, you guessed it. We need to pass a list of vertices and indices, and for each 2 vertices, OpenGL will rasterize the line, which in our case means it will connect the 2 vertices together and create a line of pixels. We need to define a model with 8 vertices and 24 indices to connect these vertices together. So we will implement a class called wireframe model, which will have the data of the model, and also a method to create it from an AABB, because our colliders will be defined by that. Also, if you remember the last devlog, chunks also have an AABB to define their borders for the frustum culling. Well, we can use this data to create their own wireframe model and show their borders. Enough theory, we need to implement the wireframe model, but also a new renderer with the new shaders and stuff, so let's get coding. Here I define the wireframe model class. This is the code to generate the model of a box using its minimum and maximum vertices. Okay, here it is. Actually, we can see that every chunk has the same box. It is only shifted. So what we can do is to simply generate one model and for each chunk, just change the position of the box in the shader. So we store and upload the data once and render it multiple times. We already do that for 3D models. We only store and load the models once and then render them in batches, just by translating and rotating the model for each entity. Okay, now it is looking nice. What we need to do though is to be able to disable the rendering. So what we'll do is to create a debug class that will handle our debugging tools. So now, in order to use the debugging tools, we first have to enable debug mode by pressing F1. Then, when pressing F2, we generate the wireframe model of the chunks if it is not already generated, and then enabling the rendering. By pressing F3, we do the same but for colliders. This is optimized because we only generate the wireframe models when we want to use them. So by enabling debug mode, you know that you'll slow down a little bit the engine, because when enabling a tool, models will be generated. I also added a method to destroy every wireframe model if they are not needed anymore. As you can see in the debug class, there's also a tool called timing. I already used it in the last devlog to calculate the amount of time rendering takes. Thanks to this tool, I can monitor the time certain parts of the code takes, like terrain generation, terrain rendering, model rendering, etc. However, this class is just a sketch for now, but later it will be useful to monitor performance more deeply, show graphs, etc. That's it for this devlog. Now we can clearly see the colliders and the chunk borders, which will be super useful when implementing physics, and later for a lot of other mechanics. In the next episode, we won't be implementing the physics engine. That's for a good reason. There's a problem in the hierarchy of the engine. And implementing physics will make next features hard to code, especially multiplayer. So next episode, we'll fix that problem by reorganizing a bit the script and separating the client from the server. This is going to be super interesting. And now I have an announcement to make. The release of thibsworkshop.com, a website still in construction where you'll find infos about me, my projects, and programming tutorials and tips. I'm also making a website for Voxand, voxand.thibsworkshop.com, where you'll find a roadmap of the game and a blog where I'll make weekly posts to show what I did in the week and explain mechanics I don't show in the videos. More on that on the next devlog. I hope that you enjoyed this video as much as I did making it. If you did, then consider subscribing and leaving a like. It helps me a lot. Thanks for watching.